Exercise 1.5 question 3. Recall, pi is defined as the ratio of the circumference, say C, of a circle to its diameter, say D. That is, pi is equal to circumference upon diameter of any circle. This seems to contradict the fact pi is irrational. How will you resolve this contradiction? So first try to understand this question. The pi is a ratio of circumference of any circle to its diameter. And we know what are rational numbers. Any rational number is of the form P upon Q, where P and Q are integers and Q is not equal to 0. So the value of pi is also looking like this one, C upon D. C is circumference, D is diameter. So normally circumference and diameters are any number, like any integer or any rational number, which this value of pi, C upon D, looks like any rational number P upon Q, where P and Q are integers, but they are not similar. Pi is actually irrational. So how will you resolve this contradiction? Contradiction means here we are saying that pi is just like this one, but it is actually an irrational number. Now I am explaining why pi is irrational. The reason is either of any these two is always, any one of these two is always an irrational number. For example, let me draw a circle with diameter root 2. I have earlier told you how to represent root 2 on a number line. For this I am going to draw a number line. Let me take 2 points on at equal distances. Then let it be 0, this be 1. Now if I draw a right angle here at 1, like this, this is the perpendicular line at 1, and now let me cut 1 unit on this vertical line. This is 1 unit. So this, now let this point be A, this be B, and this is O. If I join this OA, I have got a right triangle. Now this base is 1 unit, this AB is 1 unit. So I can calculate this OA by Pythagoras theorem. OA square equal to OB square plus AB square. Hypotenuse square equal to base square plus perpendicular. So 1 square plus 1 square is 1 plus 1. So OA square is 2. So OA is root 2. When we transpose this square to other side, it becomes root. So this length is root 2. Now I can measure this length in my compass like this and bring it down like this. So this length from this O point to, let this point be C, OC is root 2. Root 2 we know is an irrational number. So if I measure, I have measured this. So let me mark these 2 points. This is root 2. Now this root 2 cannot be measured on a scale. Suppose if you want to measure it on a scale, you would never be able to get that this is root 2. By scale you cannot measure. We know that this length is root 2. So if you mark these 2 points here, these 2 points, this one and this one, I have taken this width equal to this root 2. So let this is O, actually this is C, and if I join this, now I know that this is root 2. Now taking this OC as diameter, if I draw a circle like this, let me bisect this OC. So this is the midpoint of OC, let it be Q, and now put compass on Q, measure it till O. So let this be the radius, and now let's draw the circle. So this circle which is passing through O and C here, this is its circumference, this one. You can measure this circumference also. How could we measure circumference? Put thread over this circumference, and till this point it will just overlap this circle, and then hold that thread on, and then you can measure it on the scale. You will find that the circumference is coming in some rational number. It could be any decimal number, but it will be a rational number. But look at the diameter. What diameter is this? This is irrational. So if we have to calculate the value of pi, it will be like circumference upon diameter, as it is given in the. But look at this circumference. Circumference is rational. If you measure this, you will get a rational number. But look at the diameter. Diameter is irrational. So this as a whole, this pi is irrational, because in previous question, in first question of the same exercise, there was a number like 1 upon root 2. This I have told you as a whole is irrational. This 1 is rational, this root 2 is irrational. That's why this whole number is irrational, because if any rational number is divided by any irrational number, the quotient as a whole is irrational. So that's why this pi is irrational. So actually what happens, the pi is always irrational because either C, that is circumference, or D, that is diameter, is irrational. One example I have taken here. In this example, I took this diameter irrational. We got this circumference rational. And the ratio of rational and irrational is always irrational. Similarly, sometimes, or it may be possible that your diameter is rational. For example, you take diameter equal to say 5 centimeter. I am taking this from here 10 to 15. This is 5 centimeter, and this is the midpoint. Now this OC, or let it be any other MN. Now I have taken MN as 5 centimeter, and this is the midpoint of MN. Let this point be P. If I draw a circle like this, slightly. So let this, so if this Mn is 5 centimeter. In this case, when you are going to measure this circumference, you will find that this circumference is irrational. So again pi will be circumference upon diameter. In this case, you will find that circumference is going to be irrational. So irrational, because we have taken this Mn as rational. So again, irrational upon rational is going to be irrational. So pi is always like this. If diameter is, if circumference is rational, its diameter would be irrational. If diameter is rational, if circumference is going to be irrational. So any one of these two will always be irrational. Any one of either C or D. So this is its answer. This you have to write. All this that I have done, it is not necessary to do. This I have done only to explain it to you. So the pi is always irrational because either C or D is irrational. It means when C is rational, D is going to be irrational. So this makes pi irrational. So when D is rational, C becomes irrational. Again pi becomes irrational.